Scientists and mathematicians often speak about the concept of beautiful equations. Many equations have been suggested as being in this group. For example, E equals mc squared is one of these. I would like to suggest one which is found in medicine, and this defines the level of herd immunity required in the population to stop an epidemic of that infection. The equation looks like this. Beginning with the left-hand side, QC represents a value known as the critical immunisation threshold. Let's imagine a population of people. Imagine many people in this population have been immunised against a disease. They are smiling. Usually though, despite good levels of immunisation, there will always be people who are not immunised. They may have been vaccinated and for some biological reason the vaccine does not work as it was supposed to. Or they may not have been vaccinated at all, for health reasons or for some other social or personal reasons. The threshold value represents the proportion of the population that should be immunised to achieve herd immunity. For rubella, this is 0.80 of the population, or 80%. Infections will not be able to invade this population. Individuals may contract the disease, but infectious individuals will not be able to spread the disease throughout the population. Returning to our equation, the critical threshold number is related to R0. This is the basic reproduction number. This is the number of people one infectious person would infect. This is a difficult number to measure, as the population that is infected should be totally naive to the infection. There are, of course, other factors to do with the length of time the person is infectious for. For rubella, for each infectious case, this leads to a further 5 new cases. Therefore, for rubella, R0 equals 5. All diseases are different, and some infections have lower R0s and some have higher ones. Measles, for example, has a considerably higher R0. When introduced into a naive population, each case will infect, on average, 15 more people. R0 is a critical value in epidemiology. When R0 is a value less than 1, the disease will not have sufficient momentum to maintain itself in a population. When R0 is greater than 1, the disease may persist in a population. This may lead to epidemics or a chronic endemic infectious burden for a population. The key to getting rid of an infection in a population is to interrupt the R0 until it becomes less than 1 in that population. At that point, it should be possible to eradicate the disease. Let's look at the vaccine that is aimed to protect against measles, mumps and rubella, known as the MMR vaccine. As we have discussed, there are 5 new cases from each single case of rubella. Therefore, QC is calculated as 0.80, which means that vaccinating 80% of the population against rubella will protect the population from new outbreaks. Mumps has an even lower R0 at just 4. Therefore, the population will be protected with just a 75% immunisation rate. Measles, by contrast, has a high R0. We have seen that this is a number around 15, and therefore QC equals 0.93, or 93%. This is a high number and informs the policy for the UK government to achieve a 95% coverage of the MMR vaccine to achieve herd immunity for all 3 diseases. I know this isn't Einstein's work, but it has enormous implications for medicine, society and health.